Hello, everyone. Good morning here, and good evening, good afternoon. My name is Paul Buffa, and you're here for part 4 of the Introduction to SQL course. This will be the last session that we're running, and I'm really excited to walk through today's material because it's going to get into some advanced SQL topics, so things that are a little bit more difficult than what we've covered already. So once again, I'm joined by the team here with Allison and Wayne, who will be helping out TAing. So if you have any questions, just post them in the chat or in our community Slack channel. We'll be willing to help you out and figure out what the issues are. So today we're going to cover some new stuff. Here's a little list of what we've covered so far. So we've done a lot, right? We've covered sort of the basics of SQL. We've gone through the main different types of statements, the different clauses for pulling data. We've gotten to joins, filtering, and then last session yesterday went through a ton of different functions that are really helpful to know when you're working in SQL. So hopefully by now you're feeling pretty comfortable with the basics. At the very least, you could read a SQL query and kind of understand what's going on and be able to write your own for, again, some of these more elementary sort of stuff. And today, again, we're going to get into some advanced SQL. So these are the things that I think are really fun, really powerful with SQL. One of the reasons I like to use it so much. Specifically, we're going to spend a lot of time today on this first part, the window functions. So window functions are an area of SQL that, to me, show a lot of the value of working in SQL. Many times people like to pull data, from a database in sort of its raw format and then work within another programming language because they can do more with it there. And windowing functions is that one area in SQL where it actually replaces a lot of that other work. So you may not need to actually pull in raw data and format it in another language, whether it be JavaScript or Python or R. Windowing functions often let you do a lot of that work all in SQL. And there's a real benefit to that, right? When you can work in SQL, often the sort of data manipulation, the data pulling process is a lot faster because SQL is great for pulling large, vast amounts of data. So really excited for this one today. We'll also walk through with statements, query optimizations, a little bit, not too much there. You could teach a whole course on query optimizations, but we're going to just talk about it briefly. A little note about different SQL dialects, and then we'll talk about the assignment as well. So for this course, if you're interested in getting a certification, you have to complete our assignment, and we'll walk through that at the end of the class today. So, as I mentioned, we're going to start off with window functions, and this will be a good chunk of today's session. So, what are window functions? The sort of formal definition, a window function is a SQL function where the input values are taken from a window of one or more rows in the results set of a select statement. Okay, it's kind of a jumble up of words there. But essentially, what a window function is, it's a function that allows you to manipulate a group of rows, right? A window of rows. So you've got these rows that you're returning in your select statement, and the window function will use that to do some sort of manipulation. So you can think of a window here in a few different ways. A window could be just like a hard-coded number of rows. I want to look at, the 2 rows prior and the 2 rows post this row that I'm looking at right now. It could be a date interval. I want to look at, the 3 days prior and the 3 days post, or it could be some sort of condition, like I want to do things by some categorical value, or I want to do it by an ID, like a customer ID, or just some sort of logical statement. So there's a bunch of different ways you can define these windows. And depending on your use case, you might want to try one or the other. And again, any point here, feel free to ask a question in the chat. Happy to walk through that. So here's just a sample data set we'll do for the basic window function example. So it's some grocery data I made up. It's got 3 columns. There's a category. So there's fruits and vegetables. There's values for each one. So for fruits, there's different fruit names, and for vegetables, there's different vegetable names. And then there's amounts for each of them. So let's just say like the number that were purchased, something like that, right? So there was 10 apples, 6 oranges, et cetera, et cetera. So here's an example of a really basic window function. So what this window function does is it assigns a row number. Oh, and yes, there's a question about the link. If someone could share the link to the notebook today, that would be great. So there's a function here, a windowing function for the row number. And what this will do is it'll create a number, a row number for each of the rows, depending on how we've defined the window here. So the way you write a window function is you often declare the function name. Sometimes it takes an argument, sometimes it does not. And then we're going to write this over. And the over there is kind of the cue to SQL that we're using a window function. And then in the parentheses, we're going to define this window. So the way we're defining the window here is we're doing a partition by a value. So we're going to use a categorical value here, which is just called category, to be that window, that partition. So we're going to group them basically by the different categories, which there are two, right? There's fruits and there's vegetables. And then we're going to order by the amount. So we can define this window and then we can order the values by something. So here we're going to order it by the amount. That's a numerical value. It's a good one to use for sorting. And we're doing it descending, so it's going to go from the largest to the smallest. And you'll see here now, if you look at the row number results, it increments by each of the categories. So starting off with fruits, it's going to start at 1. And then it's going to go again in that order of the amount. So it starts with the largest first, and then it goes down to the smallest. So it goes 1, 2, 3, 4 for the 4 types of fruits, and then it's going to be 1, 2, 3, 4 for the 4 types of vegetables. So it's making these windows by category. I'm defining that using this partition by expression, and then the order is going to be by amount. Now, I don't have to specify an order here. I could just leave the default, which will just be whatever the order happens to be in the database. So you can exclude that if you like, but often you're going to see it written like this, where there is some sort of order. Usually, especially with like a row number function, you have an order in mind that you would like. Maybe that's not just the default what's in the database, but it is, again, optional. So again, here, just a little emphasis with some diagrams. You're going to see the window is that grouping there. And then the order by goes by the amount. Just before that, we have a question here. So what's the difference between a group by and a partition by? Is the partition by only used with window functions? That's right. So group by is when we're going to be aggregating the results in a select statement. And a windowing function, the partition by, is how we're going to define that window. So there are kind of two different phrases there. It's important to note, and we'll talk about this a little bit later, is that a windowing function can use aggregated values, and you can aggregate with a window function, like in addition to. So you could do an aggregation function and write a windowing function on top of that. But a windowing function doesn't aggregate in the way that a group by does. And we'll explain that a little bit more in a little bit in the session. So windowing functions do work with many aggregation functions like summing. So if I wanted to maybe add up these amounts in a windowing function, so adding them across these different rows here, I could use an aggregation function. And any aggregation function can be used as a windowing function. So here I'm using sum. It could be average. It could be min, max. Any of those ones we went through yesterday, all those basic aggregation functions. So here, what it's going to do, it's going to sum the amounts by category. We're going to partition by category and order by the amount. So if you can see what's going on here, essentially what it's doing, it's doing sort of a cumulative total, right? So it's partitioning it by the different categories. So it's partitioning it by the fruits and vegetables. It's ordered by amount, and then it's adding up those amounts. So you'll see the first record is just equal to the amount from the first row. The second record there, it's adding in the previous row and the current row. So again, I just want to emphasize this again. It's doing some aggregation for us, right? It is summing rows together, but it's taking the values that exist in that select statement, right? So it's actually, the amount is already there. It's already a computed value or just a value available in the database, and it's adding up those rows. I think of a windowing function as kind of running after the whole query is run. So imagine like you might have a query run, and then you're going to do this sort of windowing exercise on top of that. And it's important to note again when we talk about it with the relationship to group buys, because the windowing function is going to be kind of separate from the group by. It kind of comes after the group by if you're going to do some aggregation in addition to a windowing function. So common window functions you're going to see, row number is a very good one. If you want to just create an ID for a bunch of records, it can be really helpful. If you want to figure out a sequence to something, row number is really great. So you want to know like the first, second, or third customer order, for example. You're going to use a row number. Rank is another good one. So you could do basically a row number, but you're ranking it based on some value. So it's going to create a number based on another sequential number. Lag and lead. I'm not going to go through these ones too much today, lag and lead, but they're good ones to know. If you just want to get like the previous record or the next record, lag and lead are really helpful for that. Like, for example, imagine you've got like a database of customer orders and you're looking at one order in particular. You just want to know what the previous order was. You can use lag and lead for that. So it's a pretty powerful one. And then again, all aggregate functions. So sum, average, count, all of those are going to work with window functions. So I talked about one use case where the window is a categorical value, right? And we used partition-by to define that window in an order by. I noted before that you don't actually need an order by. It's an optional argument, although it's often used. And there's also other ways to define these windows, right? So partition-by is one way to define the window. You can also define the windows just by naming the number of rows you want to look at, or through different date intervals. So the first one we'll look at is through naming the number of rows, and this method is called framing. You can define, I want to look at the previous row or the previous 2 or 3 rows or the following 2 or 3 rows. And we're going to use those terms, those expressions, preceding and following. And to note, you can use this in addition to the partition by and order by we saw before if you want to add a ton of logic there. So maybe you want to partition by category, but only look at the previous row. You can do all these things together. But yeah, this is another way that you can define the window. So here we're looking at that example again, same data set. And now instead of doing our partition by the different categories and an order by, we're just going to do one of those framing methods. So we're going to define the rows are between the previous row and the following row. So I just say this by saying rows, and then I give this between expression, and I'll define 1 here as preceding and 1 following. So you'll see here now when it adds up apple for the moving sum, it's only adding the following row because there is no previous row. And then for the second record here for orange, it's adding in the previous row for the apple amount and the next row, the following row for the pear amount, which adds up to 18. So you can see how it's kind of moving along each row here. And just a little visual cue to help emphasize this. Run this row here, right? It's looking at the preceding and the following row, in addition to the current row. So you can think of it as that range, right? We talked about between functions before a little bit. So it's going to define this range, this sort of extent you're looking at, and everything that falls within that extent will be added up. So another option here, if you don't want to necessarily define, one value for, the number of rows you're looking at preceding or following, you can use this term unbounded. So you can say everything previously or everything following, I want to include that. So this is useful for like a cumulative sum sort of metric. So if you want to add up everything, that's what we're doing here essentially, right? It's just going to add up everything previous. And this one actually goes to 1 following. So it's a little, actually not really a cumulative sum. You would probably just stay to the current row. But it'll add up everything previous here. So it kind of makes a running total. And then again, as I just noted, so you could also just define the current row as the last row you want to look at. So you don't have to use this following phrase if you don't want to. I think you could also just write 0 following if you like. That'd be the same thing as current row, but, there is a current row expression you can use here. So again, you can also do this in addition to partitioning. You don't have to use one or the other. So here I'm partitioning by the category, and I'm defining that I want to look at the one row preceding and the unbounded following. So it's going to do it by each category and add up everything, one row preceding and everything after. So you can see how it changes the results there. Like for leaks example, it's adding up only one row previous, so it adds up to 7 there, and it's doing it by each category. Now, the last window you can define, another way you can do it again is by intervals. So here we're defining interval by days, and it's going to function similarly. Instead of saying rows, though, we're going to say range between, since we're working with time now. So range between, and we define the interval that we're looking at. This is obviously going to work only if you've got a date value there. You have to make sure that you're handling with a date, otherwise it won't work. But if it is a date, it's going to understand that dates have special properties. There's intervals when it comes to dates. So you could use days, weeks, months, whatever you like, years, and define it this way. So similar, just a slightly different syntax. So you're going to say the interval preceding and the interval following. Same thing as before, though. You could use just the current row or something like that. Okay. Why don't we start working with these window functions and testing them out? And again, at any point, feel free to ask your questions. Happy to walk through that. So here we are. I think we've shared it out, the notebook for today. So like before, if you want to fork this, hopefully it works. Again, I've loaded in the data set this time as file attachments. So hopefully that works for everyone. There's no issues with loading. But if you'd like to just follow along and just watch, that also works great. So whatever you like to do, that's going to work great. Looks like there is one question that comes up. So for the date intervals, will it also work on DTTM, like a date timestamp? So yes, it should work fine for a date timestamp. But if there's any issues, you just have to coerce it into a date type, which again, you can do through that : :d. All right, so the first prompt here we're going to walk through is to create a new query using a window function. So we're going to create a row number for each product, partitioned by category and ordered by the launch date. So let's first look at this table. So we're going to use this products table. We've used this a bunch throughout the course. I'm just going to pull everything from that table using select star. Here we go. Here is our products table. There's 36 rows. And all of our product information. So what we're going to do here is we're going to create a row number for each product, and we're going to partition by category and order by the launch date. So the last column here is this launch. It's when the product was first introduced. And we're going to use that launch date. So we will do the row number function. So we're first just going to call that function. And then to say we're using a window function here, we're going to do over partition by, we're going to use the category value, so category. Then we're going to order by the launch. So that's that date there. Now, it will default to doing the order ascending. You can specify descending if you like, but we can just leave it as ascending, then that works fine. So we'll call this as row number. And then we can pull just all the rest of the values if you like. Run this. You'll see now I've got this row number assigned. You'll notice that it starts at 1 for the first value in the category vegetarian, and then it goes up to 8, and then it starts at 1 again for the rows starting at classic. Looks like someone was getting an error. Looks like you just maybe misspelled the products table there. So hopefully if you just correct that, and looks like it's actually a pretty good error message. It's telling you how you might want to rename that table. So yeah, That's pretty simple, right? That's essentially the simplest windowing function. So you just, again, row number, call the function. Now say we're going to use a window by saying over here, the over expression, and then in parentheses, we're going to give it that window logic. Now, if I did an order by launch, just going to do it in the default order that's in the database. So it looks like, yeah, it just happens to be 2019 and 2021. And if I add in the launch there, it's going to update that. And if I change it to descending, it should now swap. Looks like the Sicilian pizza and the veggie pizza. Yep, you'll see now Sicilian's at the first and veggie is second. Any questions so far? Again, this is like the simplest version of a window function, but more complex than the stuff we've done before. All right. So let's get into a little bit more advanced windowing functions. So here we'll do a rank function. So this one says rank products by category based on the number of orders. So we're going to need to pull the number of orders by category and product, and then we're going to rank them. So why don't we start off with the simple part first? We'll just do that query without the windowing function. So we're going to pull from the products table, and we're going to pull the number of orders. So for that, we're going to have to do a few joins. We'll start off with the products table. We're going to join to order items, which is a way to join products to orders. We'll do join on the products SKU equals to order items SKU. We're going to join to orders on the order items order ID equal to the orders ID. This is just, syntax for how to join these tables together in this database that we've been using. All right, so now we have a way to get all the data lined up, and we're going to write this query that says we're going to pull up maybe the product's name, product's size, product's category. And we're going to count the distinct number of order IDs to get as number of orders. So we'll call it number of orders. Since we're going to aggregate this data, we're doing a count, an aggregation function here. We're going to do a group by, and we're going to have to group by all the different columns that we've selected that are not aggregation. So the name, size, category, and as I've done before, I'll use the shorthand of 1, 2, 3, meaning the first, second, and third column we're going to group by. So, just had a typo here. Should be orders, not order. There we go. So now we've got just a count of the number of distinct orders by each of the products, including their name, size, and category. So now we're going to rank these by category to see what's the most popular product for each of the categories here. So we're going to add in this rank function. So for that, we're going to again specify that we're using a window function here. So I'll put an over, and then in parentheses, we'll add in our logic for what that window is. So again, like before, we're going to use this category as the window. So we'll partition by the products category. So just going to copy and paste that. And now we're going to order by this numerical value to show the ranking. So we'll order by count distinct orders ID. Right, we're going to order by this. That's the value. And since we probably want the top ranking one first, so with the most orders, the order will be in descending value, right? So we want to have the largest with the highest rank, or I guess the lowest rank, right? One being lower than another number. But usually one means the top. So we're going to order this descending. We'll call this as order rank. I'm going to run this. You'll see there's now a new column called order rank, and it's correctly ordering the different products based on the number of orders here. So you'll notice also the results kind of changed, right? The order of the results, it's automatically sorted them based on the largest to smallest by each of the different categories. So first, we're starting off with vegetarian. The number one order in terms of number of orders is a veggie small. The last one being a medium Sicilian. And then if you get to the classic categories, you'll see now the number one order is margarita, medium. And then for specialty, the number one order is barbecue chicken, small. All right, just checking for any questions again, because everyone's now already mastered window functions. They're really powerful, right? Like this is the sort of stuff that you may not think you can do in SQL, that you might need to use another programming language for, but you can do it all in SQL. And if you can do it all in one place, it's going to save you a lot of time rather than having to export to another language or another framework. All right. So let's get into another one here. And this one, we're going to combine it with some of our logic and functions we've learned around handling dates. So this one is to write a query that finds the first product ordered by each year. So I want to know, what was the first product ordered in every year that this data is available. All right, so let's do the same logic as before. We're going to need a way to join the products to the orders table. So I'm just going to copy and paste a part of this query. So I'll do my select. We'll do the from, formatting it so it looks a little bit nicer. There we go. So we're going to want that product's name, the product's size, the product's maybe category as well. Definitely going to want to look at this, the year in question. So we'll pull out the year from the order. So as they remember, the function we'll use to pull out the year from a date. It's one of the functions we went through yesterday. There was a few different date functions: date trunc, date part, and date difference. It's not date difference, so it's either date trunc or date part. And no responses yet, so I'll say the answer: date part. That's going to retrieve a part of the date here. And the arguments it takes is the interval we're looking at. So we'll put in year. The second one it takes is our date. So we'll use the order date. So orders, order date. In here, we're going to have to just, it is a timestamp technically. So I'll just, of course, this as a date. I think the chat is like slightly delayed. So I'm noticing those answers coming in now. But that's right, date part. And then we'll call this as year name. And I don't want to run this whole query because it's going to pull all 2 million orders. Let me just limit to the top 10. Well, let's take a look at it. Okay, so there we go. So it's pulling in the name, the size, the category, and it's pulling out the year from that order date. Maybe I'll just coerce this as a string, since year is more like a category than it is like an actual number. So here we go. We've got 2022, 2021, 2020. Okay, great. Now we want to do is find the first order by each of the years. So for this, how would we find the first? We've walked through one of these functions already. There's a few different ways we could do this. But I mentioned before that the row number function can be really good for sequences, right? So we could pull up that, do row number. Again, for our window, we're going to say over. Then in here, put in our partition information. So we're going to partition it by, since we want to know the first by each year, we're going to want to partition it by year. Now, this is a neat little trick I haven't shown you before, and not every SQL dialect will let you do this, but most of them now, I do believe, will let you, which is I can actually reference this name, this value here, without having to write out the whole logic for how it was created, right? Without having to write this whole function. I can just call this column name. So I'm going to partition by the year name, which I just defined in right above. I'm going to order by. Now here, since we want to know the first, we want to order by that order date, right? So order by the order date. And here we'll use ascending, but you can just specify it if we like, although that is the default. We'll call this as row num. Run this, limit to the top 10. You can now see this row number is assigning here. Noted that even though it returned 10 rows, that query took a second, right? It's not as fast as before. And it's important to know, we'll talk about this in the later part today about query optimization. The way this works is it's going to basically assign a row number to all the data, and then it's going to limit it to the top 10. So it's actually creating a row number for all 2 million plus orders, and then it's only showing me 10. So it's a pretty expensive to write it this way, right? It's going to do a lot of computation and then only give you 10 results back. So it's kind of throwing away the other 2+ million orders. So that's why that one did take a second. Okay, so now though I've got the order, I got the row number. So what we want to do is get just the top one for each year, right? So for that, we're going to order by this row number here, because it's partitioned by year, so it's just start at 1 for each of the years. So when we do that, we'll order by the row number. We're going to limit to the top 10 for now. So you'll see, there we go. I've got 10, and it's the first for 2022, 2020, 21, and then the second, and then the third for each of the following years. But then we might also want to order it by the row number and the year name. This way it shows 2020 first, and then 2021, then 2022. There we go. So now you can see it's actually showing me what the first order was for each year in addition to other years. So all I have to do now to get what I want for this prompt is just limit to 3, limited to the first 3 rows, which are the first order for each year. There we go. So you can see the first order in 2020 was a buffalo chicken pizza. And the first order of 2021 was veggie pizza. And the first order of 2022 was a barbecue chicken pizza. All right. I'm just going to take a look to see any questions. So there's a question here. Would we achieve the same goal by inserting a left join? So a left join here, I don't know if you'd want to use that because there is a perfect match between all these different tables. So use a left join when there may not be a perfect match and there might be some missing values, and you don't want to exclude those rows where there's missing values. So here it wouldn't make any difference. It should even pretty much run the exact same speed, but I wouldn't use it here because there's no real reason to, unless I'm misunderstanding your question, if you want to rephrase. Okay, great. That's a lot of the windowing function stuff. I feel like we got through that pretty quickly. Not too many questions. So feel free to raise your hand if you've got any more thoughts about window functions, but a pretty cool spot. And we'll do a little bit more in the next section here. So as I mentioned before, a little warning about window functions. You can't do everything at once with a window function. So window functions aggregate the results across the rows that you're returning, but will not group the results at the same time. So you usually want to split this logic out. And I'll show you an example of what I mean. So here we've got a simple query. So it's going to pull up the order date, the number of orders, and it's going to try to sum those orders by the order date. So we're going to order by the order date. And for this range of 3 days preceding and 3 days following. So that's a moving average. So this data set, this California daily orders, it's going to show you orders by each day, I believe by each product in California. So this function, you would think, is just going to sum up all those orders so that I have like the daily count of orders. Oh, sorry. Actually, I believe that it's not by product, it's by store. So the row in each one of this table here, it's going to be by date and store. So there's multiple of the same dates, right? Because there's multiple stores in California. So you'll see here when I do this window function, it's not actually adding up by each day. You'll see that is actually the order date. There's duplicates, right? There's many for January 1st. Oh, sorry, my head's covering up the thing here. Let me scoot this. I can just shrink my head a little bit. No, 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 no. There we go. It's just a question mark. So not losing too much info. There we go. So you'll see here, though, it's just adding up a lot more than we would expect, right? The number is really large. And if I added a group by here, I actually would get an error message saying that there's basically, this has to appear in the group by. Very confusing. So if I just wrote in group by because I want to group it by the date, I'm going to get this kind of odd error message here, which might seem weird to you because you have an aggregation function, right? Sum of orders, and you're just defining this window. So the way you would actually solve this is you would put another aggregation function within your window function. So you're going to aggregate the sum of orders and then do a window function on top of that. So that's what I was talking about before when I was saying that the window function, it is aggregating, but differently than your group by. The window function is sort of aggregating, if you're using an aggregation function with your window function, it's aggregating the rows that you're returning. So you first kind of want to have your data in the right format. So if you're going to do some aggregation, like summing orders by day, you usually kind of want to do that first and then run your windowing function on top of that. So while this works, you could just kind of nest them. You could put your sum of orders within your sum window function. It's not considered a best practice because it's pretty confusing, right? It's kind of hard to read. It looks a little odd too, while you're just kind of duplicating the sum of orders and then doing a sum on top of that. So, little Drake meme, overly complicated select statements, no good. But breaking up your logic with a with statement is the way to go. So what are with statements? So with statements are ways of creating new sort of tables. I put tables in quotes here because they're not really tables. They're known also as like temporary tables or views on the fly. So you can basically create a new structure that you can treat like a table in your query and use that as you would any other table. And this is a way to kind of break up logic of a complicated query into smaller parts. It can slow your queries a little bit depending on how large these temporary tables are, but it will make them a lot more readable and reusable. And if you use them correctly, they can actually speed up your queries because you could make one of these views, we use a with statement, to create a subset of your data first and then use that in your query. So you're actually using less data throughout your query by first kind of defining this smaller subset. So let's just jump in. With statements are pretty simple, so I don't need to define them too much here. I'll just show you how they work. So here we're going to write a query that takes a with statement for Utah stores and counts sales by month for just Utah stores, filtering with a join. Okay. So the idea here is we're going to create a table using a with statement that is just for Utah stores. And the syntax for building out a with statement is very simple. We just write with, that declares I'm going to use a with statement as, with the table name we're going to make it. So let's call this Utah stores. And then as, and now we're going to specify in parentheses the query that generates this table. So I would select star from stores where state is equal to Utah. I just underneath now write my query. I can select star from Utah stores. So now I'm just pulling from this table that I just created. And now you can see there's one store in Utah. So it's just pulling me that one store. So I mentioned, and I think in the first session of this course, that pretty much every query we're going to write in this course, and most queries that you're going to write, are going to start with a select statement, start with that select clause. Now, this is that case where you do not, where you start off with something else. And this will be the only other thing you pretty much ever start with is going to be with a with statement. So either you're starting off with a select, you're just referencing tables that already exist, or you're going to start off with a with statement where you start defining tables that you're going to want to use in your query. Now, obviously, I could just have written this, right? I don't need to create a with statement. This is a very simple example. I could have just written this, and that returns the exact same results. But when we get to more complicated queries where there's a lot of different logic, it's nice to write it out this way because you can kind of break up those logic into smaller pieces. So rather than having one massive query that pulls from, different tables, has all these filters, all this different aggregation, you can do it in different bits and pieces with statements, which makes it a lot more readable. All right, so for this one, we said we're going to write a query that creates the with statement for Utah stores and count sales by month for just Utah stores. Okay, so if we wanted to count sales by month, we're going to use the orders table. And we're going to then have to pull out the month name. So we're going to use, again, one of those date functions. Here we can use the date trunc because we actually maybe want to return a real date. So we'll pull out the month. We'll use the orders order date. It's going to have to be, again, coursed as a date type. It's by default a timestamp. We'll call this as month name. Then we'll count the distinct orders ID as number of orders. I'm just going to take out that where there, and then we'll group by that first column. Now, I'm just going to run this. It doesn't actually use Utah stores, right? Note, when you make your with statement, you don't actually have to even use it. It'll still run. So it's not like an error if you forgot to use this table you made. So this is just, I created a temporary table called Utah stores, and then I just wrote a separate query that says, count the number of orders by month. So, obviously you shouldn't write with statements for tables you're not going to use, but it won't create an error if you did forget to use it, or if you're testing out and just drop that table. All right, so now what we're going to do is to filter for just Utah stores, we're going to join to this table. Rather than having to use a where clause or a having clause to filter, we're going to join to this table of just Utah stores, which is just one, should probably just be called Utah store. We're going to join to this to filter our results. Remember, joins, we're not doing a left join, just a regular good old-fashioned join. That's going to filter your data, if there's not a perfect match everywhere. So we'll join to Utah stores on the orders store ID equals Utah stores ID. And now I will just get the results for that Utah store. So this is a way that I'm filtering my data using a with statement and a join, right? So I created a temporary table, and then I joined to that table, filtering my results to just one store, and then I pulled the rest like I normally would. All right. Hopefully that one was not too difficult. Kind of a silly use case maybe for using a with statement, but a good one nonetheless. So now we're going to get to one that's, I think, fairly advanced. If you're able to write this query without any instruction, you're getting pretty good at SQL. So this is going to be a fun one. So here we're going to write, and this is, I think, also a more real world use case where you might really use this if you're a data analyst or a data scientist. So here we're going to make a 7-day moving average. So we can do a rolling 7-day average of the number of Hawaiian pizza orders using a with statement to pre-aggregate the orders by day. So remember before, and I was showing that example of, don't try to do aggregation, like a group by in addition to the with statement at the same time. It can make it really complicated. This is how we do that in the sort of correct way, where we break it out into smaller subsets. All right, so for this, again, we're going to start off with a with statement since we're told to do one here. We'll call this Hawaiian orders. Let's Hawaiian orders. So with Hawaiian orders as, and we can now write in here that new temporary table, the logic for that with a SQL query. So we'll do select. Now let me just grab some of that join logic from before, so I don't have to keep writing it out each time, where we join from products to orders. Here we go. Let me just fix the formatting, just get a little indent. So now we're going to join from products to orders so we can get just Hawaiian pizzas and get the number of orders by date. So if we're going to get the number of orders by date, we're going to do that orders, order date. Order date for now, like that. And we'll do another count distinct orders ID as orders. Now we want to do it for just Hawaiian pizzas. So remember, in the database, when we look at the products table, there's going to be the different types of pizzas and different sizes. So we don't care about which size it is. It can be any of those sizes. We just want ones that are Hawaiian. So we're going to have to use one of those text functions we went through yesterday to match any type of pizza that is Hawaiian. So does anyone know which function we're going to use? There's always a little delay. So I'm guessing somebody said the right answer. I'll just write this in. So we're going to use a like function, match any product name that has the word Hawaiian in it. So we'll say products name is like. Now in here, we're just going to use that wildcard %, so it can be any match. We'll just put in Hawaiian. Exactly. Looks like somebody got it right there. So the like function. And this will now get me any of the products that have the word like. I could also write it in. That's right. So if I wanted to write it out, I could write an in statement there. But this one, pretty simple. I like using like. And we are doing some aggregation, so we're going to do a group by. So I'll group by the first column there, which is the order date. Maybe I'll just make sure to order by that column as well, so it's in the correct order. Now, just to kind of test this temporary table, this with statement, I'm going to just do a select star from Hawaiian orders. I'll just cut. There we go. Now we've got a count of orders by day for just those that are Hawaiian slices. So now we want to do is make a 7-day moving average of those orders by day. So we can pull in all of this data. Now we're going to do that moving average. So it's going to be an average, right? And we're going to use that num orders. That's the value we're going to be averaging over time. And now since we're using a window function, we're going to say over, right? And then in here, we're going to define our window. So for this one, since we're talking about using the date, and we're going to use a range of days, we're not going to use the partition by, and we're not going to use the rows for the framing. We're going to use this range. So first, maybe I'll add in the order by just to make sure, again, it's in the correct order. So order by, order date, sending. Then I'm going to add in the range is between. Now for this, we're going to specify the interval. So for a 7-day, there's a few different ways you can do this, right? You know, when you're doing a moving average like this, you could either do the unit you're looking at kind of as the first day and 7 days following. You could do it as the 7 days previous, or you could do 3 days before and 3 days after, right? Different ways you can look at a moving average. The kind of traditional way, I think, is to kind of put in the middle. So you would have the average for the 3 days previous, the current day, and the 3 days after. So we'll say, so the range between interval 3 days preceding, and it's kind of long, so I like to kind of use line breaks to break up the logic. Interval 3 days following. We'll call this as our moving average. There you go. You can now see the moving average of the 3 days preceding and following. So for this one here, looks like it's saying 269. So yeah, if we added up all four here, it should equal to 2. So let's just do that real quick to make sure our logic is correct. So 619 plus 277 plus 133 plus 48 divided by 4. There we go. So it's correctly doing that moving average. So here again, we broke up the logic. Rather than aggregating at the same time as we applied this moving average window function, we did the aggregation first in a with statement, where we just counted the number of orders by day. And then we did a window function on top of that. So instead of having all in one spot, which might have made a query pretty long and pretty complex, we broke it out, which hopefully makes it a little simpler. One thing also to note, you can add multiple with statements. You don't need to have just one. So you could actually just list out multiple with statements in a row. You just use a comma in between each one. So if I wanted to, I could even write this second query as another with statement and just pull that. So I can call this, return results as, and now I'm listing out another with statement here. This, indent it. Now I've got another with statement. I could just select star from return results. Not really necessary. I'm just writing out more SQL that's doing the same thing. But you can just list out multiple with statements. So if you do want to kind of have a bunch of different snippets of logic broken out as different tables, you could do it that way. And that could be really effective, again, for very long queries. All right. I want to be conscious about time, so I'm going to move on to the next section here. I'm just going to talk about this very briefly, and I don't think we're going to have time to go through the exercise for this, but maybe we can. Maybe we can do it in a quick minute. Again, as I said before, you could do a whole course on query optimization. Query optimizations are very important. You want your queries to run fast. And if they don't, that can be really costly in multiple ways, right? It could just take more time for your queries to run. If you're working with, a real production database, that time can mean, one, you lose time because you're waiting for the results to come back. And also could mean it's holding up other people who are running queries because they kind of usually have to wait for one query to finish for the next one to start. Some versions of SQL charge you by how long your queries run. So, queries that are not optimized literally are going to cost you more money. So that's never good. It's just good just to be as efficient as you can. So it's important for your queries to run fast. There are useful commands for optimizing queries. So you can use this this clause called explain. So you literally just write explain before your query, and then it'll give you some stats on it of like basically how long it's going to take for that query to run. So that can be helpful if you want to test things out. Most SQL dialects also like store logs of queries. So if using like a service like Snowflake, you'll actually can see in their portal how long the queries took to run, how much information was retrieved. So that can be helpful for figuring out query optimization. But I'm just going to talk about just a few theories you should think about when you're writing queries. These are kind of just simple principles for optimizing queries. So try to filter your data early and often. As much as you can filter your data and reduce the number of records that you're looking at, your query is going to run faster. So if you can filter in the where, which kind of happens earlier than the having clause, you should do that. And if you can filter to a subset in a with statement and just use that subset of data first, that's going to make your query run a lot faster. So try to filter your data as much as you can. Don't pull things you don't need. You might think, oh, I'll just pull in all the data, then later I'll do some filtering, when I present my data or something like that. That's going to make it really inefficient. So you're going to want to filter your data in your SQL query early as often as you can. If you can aggregate results, return fewer results, that's going to make it run faster. As I just mentioned, create subsets of your data, with those filters in a with statement, and you can just reference that. So you're never referencing the full table with all the records. You're always referencing a subset of the table. Try to use left joins only when you need to. Don't pull in null values if you don't want null values. Again, just reducing the number of rows that you're looking at. And just be careful about duplicate rows. Check your join logic. Make sure you're not returning too many things and then filtering them out later. Again, just about a lot of SQL query optimization. It's just about trying to look at the fewest rows you need. Work with the least amount of data so your query runs fast. In general, SQL is very fast compared to other programming languages with working with large data sets. So it is going to be pretty efficient to work within SQL, but you can make it run really fast. Like you can really work with millions of records and pull it back in a second when you write an efficient SQL query. So just in the minute here, I'm just going to show you a little bit about query optimization. So here we go. So here's this poorly written query. It's got a bunch of left joins that we don't need. It's doing filtering all the way at the end, right? So we could just optimize this by doing a few things. We could just remove the left joins. We don't need that. We can move this filter for the category above rather than doing in the last part. We could do it in the first part here. So we could say where category is equal to the vegetarian at the top here. We also are pulling in all the data from the products table, but we're only using the name and size. So I could just take that out. I could do the name and size here. Right. And just by doing this simply enough, it's going to make this query run a lot faster. So again, this is a small database, so you're not going to really notice it. It might shave off a few milliseconds, but you're not going to be able to see that. But just doing something as simple as this, I'm just returning less data. I'm filtering up earlier. I'm taking out unnecessary left joins. It's going to make my data run faster. I see a few questions coming up. Let me just quickly talk through the last bit here, and then I'll go to those questions if people have an extra minute. So this course we went through DuckDB as the SQL dialect that we're using. It works great for instructional purposes because you don't have to connect to a remote server. I can run these databases in the browser on the fly. But there's many types of SQL out there. And just to note, like most of what you learn in this course is going to work there. There is differences between each version of SQL, but for the most part, the stuff that we covered is going to be the same. So if there is any differences there, they're usually kind of small syntax differences, and usually the docs you find are going to be pretty good at showing the differences there. But just to note, like things you learn, you don't have to use DuckDB for this. Almost all of it is just going to translate immediately to other languages, and some stuff actually might be easier. In some languages, like that handling of dates versus timestamps is more intuitive. You don't have to kind of change the data type on the fly. So just to note, you will be able to apply this to any version, whether using MySQL, Postgres, Snowflake, all these different types. And for the last bit here, the course assignment. So I'm going to share out. We'll do it in the reminder email. We'll do it in the Slack channel, just the assignment that we're going to have for this course. So it's right here. It's going to be in that same collection as the course. So if you click on that SQL course collection button, you can find it there as well. What you're going to do is you're going to fork this notebook and complete the prompts. So pretty straightforward. It's going to, again, use the same data set, so you'd be pretty familiar with. I try to be really explicit with the prompts to say exactly what you're doing. If you have any questions, though, just ping me. You can email me. I've got my email information there, or you can ask me on Slack. Don't spend too much time trying to figure out like which column I'm supposed to be using. I want you to focus on the SQL, functions and the clauses, not just the specific names of this mock data set. So if you have any questions there, just ask me. I've listed out the tables that you're going to want to use and the columns you're going to want to look at. But again, if there's any confusion, let me know. Hopefully, I think it should take about 1 to 2 hours. But if it takes you much longer than that, again, feel free to ask questions. I'm happy to help out. The last bit here is to promote the next course coming up. And let me move my head so you can see what it says. There we go. So one of our team members, Robert Corsara, has done great courses, also free. It starts next week on advanced data visualization. So he's done one already on the best practices for basic data visualization. That course is also free to watch on YouTube on our YouTube channel. There's another one next week, so if you're interested in signing up, go check that out. All right, we're at time. So I want to say thank you to everyone. It's been really fun teaching this course. Really great to see all the questions come in. Hopefully, everyone learned a lot. And again, if you're interested in getting that certificate program and would like to do the course assignment, that information will be sent to you soon. I'll stick around just for an extra few minutes for these questions that have come here. But if you have to drop, totally understand. So thank you again. All right, so it looks like I've got a couple questions. So there's one question here. When you do a 7-day moving average, shouldn't the first seven values be missing? So yeah, again, that depends on that definition of the window. So there's different definitions for moving average. There's ones that are strict that say like you have to have at least 7 days to generate that moving average. So you can define a strict one there. Here for SQL, I don't know of an easy way to do that. You might just have to write in like a conditional that says if there's not 7 records, don't return the value. Um, but some to say you want to do it for the previous 7 days or the following 7 days or 3 days previous and 3 days following. So depends on your definition. So one question here, is it possible to create graphs using SQL? So SQL is not going to do any graphical displays. So it won't be able to generate a chart for you. You're going to want to use another language for that. So it's great in observable to use something like observable plot to visualize your data. So you would just return the results and then use plot to show the results. But SQL itself is not going to do that visualization. And one more question here. Is it possible to use window functions across 2 dimensions, like say 5 days plus, 5 days minus, and a store radius of +5 and -5? Absolutely. So for that store radius one, you might want to partition by that. So you can add that logic in as your partition by. But you can add up all those different windowing logic together. So you can do partitions. You can have multiple partitions. You can you just put a comma between each partition. You can add in the number of rows, the range, all those things in conjunction. All right, I think that's all the questions. So thank you again. Thanks for those who stuck around a little late. And I'm looking forward to seeing your assignment. All right, thank you.